Welcome back to Programming Fluency. This is section 10.4, Makefiles and compiler flags. You can now compile and link files by hand, but typing those gcc commands every time is tedious and easy to get wrong. In this video, you will automate the whole build with a tool called Make. Let's begin. You now know how to compile each file separately and link the object files, but typing all those gcc commands by hand is tedious. You have to remember which files changed, which headers they depend on, and the exact order. Miss one and you get a silent bug. In this video, you will learn Make. You describe the dependencies once and make figures out what needs rebuilding every time. This is the plan for this video. First, your first Makefile, targets, dependencies, and recipes. Next, how Make decides what to rebuild. It walks a tree and checks file timestamps. Then variables and pattern rules. CC, CFLAGS, and the %.o:%.c rule. After that, compiler flags that matter. -W_all-G, -O2, and -LN. Finally, the two classic Makefile bugs, spaces instead of tabs, and a missing dependency. Let's see why the manual build is fragile. For the physics project, building takes 4 commands. Compile each of the 3 files, then link. Now suppose you edit physics.c, you have to remember to recompile it and relink. But what if you also edited vec2.h and forgot that main.c depends on it? Then main.o is out of date. It was built against the old header. You link it against the changed code, and the program crashes silently or produces wrong results with no compiler warning at all. This is exactly the bug Make prevents. This is your first Makefile. It is a text file named Makefile with no extension. It contains rules, and each rule has 3 parts. Look at the top rule. The target is program the file to build. After the colon come the dependencies, main.o and math_util.o, and on the next line, indented with a tab, is the recipe, the shell command that builds the target. That tab is critical. It must be a real tab, not spaces. So the 3 parts are, first, the target. That is the file to build like program. Second, the dependencies. Those are the files the target needs, listed after the colon. And third, the recipe. That is the command that builds it, indented with a real tab. Now you just run Make in the same directory as the Makefile. The first time, nothing is built yet, so Make runs all 3 recipes. It compiles both files and links. Now edit math_util.c, changing one function, and run Make again. This time Make does only 2 commands. It sees that math_util.c is newer than math_util.o, recompiles just that file, and relinks. Main.o was untouched because main.c and math_util.h did not change. Run Make a 3rd time without changing anything, and it says, program is up to date. Nothing to do. Make did all the dependency tracking for you. How does Make decide what to rebuild? It uses file modification timestamps. For each target, it checks the dependencies. If any dependency is newer than the target is out of date, and Make runs its recipe. This figure shows the dependency graph. At the bottom are the headers and source files. They point up to the object files, and the object files point up to the program at the top. Now trace it. If you change math_util.h, both object files depend on it, so both are rebuilt, and then program is relinked. But if you change only math_util.c, only math_util.o is rebuilt, and then program relinks. Make walks this whole tree automatically, so you never have to track it by hand. Typing GCC and the same flags in every recipe is repetitive. Makefile variables fix that. You define a value once and reuse it with a $sign and parentheses. Here, CC equals GCC and CFLAGS equals -W all -G, then every recipe uses $CC and $CFLAGS instead of writing them out. This has two benefits. First, change once, apply everywhere. Want to switch to Clang? Just change CC, want to add a warning flag. Edit CFLAGS in one place. Second, readability. The flags are defined at the top where you can see them. The standard names are CC for the compiler, CFLAGS for compiler flags, and LDLibs for libraries. When you have many object files, writing a separate rule for each gets repetitive. A pattern rule solves that. Look at %.o:%.cvis says. Any .o file is built from the matching .c file. The %sign is a wildcard that matches the same stem on both sides. Inside the recipe are automatic variables. $@ means the target. $less than means the first dependency. And $caret means all the dependencies. So $CC, $CFLAGS, -C, $less than, -O, $@ compiles each source into its object file, whatever their names are. One pattern rule now covers your whole project. There is one more piece. The flags $M D and $M P tell GCC to write out a small .d file for each object, listing the headers that object includes. The -include line at the bottom pulls those files in. Now, when you change a header, Make knows which objects depend on it and rebuilds them automatically. You never have to list header dependencies by hand. Some targets are not files at all. They are just command names. The most common are clean and all. Clean removes all the object files and executables so you can rebuild from scratch. Its recipe is rm-f *.o program. The -f flag means do not error if the files are missing, and all is a convenient default target that builds everything. Now one subtlety. If someone created a file literally named clean in your directory, Make might think the target is up to date and skip the recipe. To prevent that, you mark these as phony with .phony: all clean. That tells Make they are not real files, so their recipes always run when you ask for them. The CFLAGS variable is where you configure how GCC compiles your code. A few flags matter for every project. -W all and -W extra turn on warnings. They catch likely bugs at compile time, like unused variables. Many bugs that would take hours to debug at runtime are caught in seconds by a warning. -G embeds debug information, the line numbers and variable names that GDB, the debugger you will meet in the next chapter, needs. Always use it during development. -O2 optimizes for release builds. During development, use no optimization because it is easiest to debug. And -LM links the math library, needed for functions like square root. A typical development setting is CFLAGS equals -W all, -W extra, -G. Some functions need an external library. Square root from math.h needs -LM, but -LM is a linker flag, not a compiler flag. So it belongs in the link recipe, the one that produces the executable, not in CFLAGS. Look at the Makefile. LDLIBS equals -LM, and it appears only in the program rule at the link step. Why? Because when you compile with -C, you are just producing an object file. No linking happens, so library flags are meaningless there. The compiler just generates code that calls square root. The linker resolves that call later by finding the math library at the final link step. This is the most famous Makefile bug of all. Spaces instead of tabs. Look at this rule. The recipe line under program is indented but with spaces, not a tab. When you run make, it says missing separator stop. Why? Because make requires a literal tab character at the start of every recipe line. Spaces look identical on the screen, but they are a completely different character to make. The fix is to make sure the recipe line begins with a real tab. If your editor converts tabs to spaces automatically, turn that off for Makefiles. This is the second classic bug, and it is dangerous because it is silent. A missing header dependency. Look at the rule for main.o. It lists main.c as its only dependency. But main.c also includes stats.h. That header was left off the list. So when you change stats.h, say you add a field to a struct, make does not know main.o depends on it. So main.o is not recompiled. It still uses the old struct layout, while stats.o uses the new one. The two disagree about the struct size, and you get memory corruption, garbage output, or a crash, with no warning at all. The fix is to list every header a source file includes. Main.o depends on main.c and stats.h. Let's recap. Make is a build automation tool. It reads a Makefile and runs only the commands needed to bring your project up to date. Each rule has three parts: a target, its dependencies, and a recipe indented with a tab. Make compares file timestamps. If a dependency is newer than its target, it reruns the recipe. Otherwise, it does nothing. Variables like cc and cflags, and pattern rules like %.o:%.c cut down repetition. For flags, remember, -w all and -w extra catch bugs, -g enables GDB, and -O2 optimizes, and -lm belongs at link time, not compile time. Finally, phony targets like clean and all name actions rather than files, and watch for the two classic bugs, spaces instead of tabs, and a missing header dependency. Next, your programs now build cleanly across many files, but building is not the same as behaving. In the next chapter, you will learn to debug C programs with GDB.